Hey everyone, in the previous session we have seen the system requirements and the overview of the mini project we are going to do. So in this session, in this video, we are going to see the data architecture of the project. So what a data architecture is? Data architecture is one of the important and major components of a big data project. So how would this data architecture has to be? So I forgot to mention another role in big data ecosystem, which is a data architect role, who is responsible for actually designing the architecture of the data. They have to be able to provide a solution which is scalable, reliable, and also cost effective, and at the same time secure. So a data architect role is to basically design the architecture of what are the tools which are required, connecting the dots, and how the solution will be scalable and effective. So that is the role of the data architect. And now we are going to discuss about the architecture of this mini project which we are going to do. So we have initially there will be a data extraction process, data processing, and then data storage, followed by querying and visualization. So initially we have the open APIs in the internet to extract the streaming data using the tool known as NiFi, which is very easy to use and an open source tool which we are going to discuss in the further sessions. So using NiFi, we are going to extract the streaming data at every 5-minute interval of time, and using these processes. So invoke HTTP is the processor in the NiFi which is responsible to grab the data, in which we configure the HTTP URL from which we want to grab the data, as well as different configurations for that API to get the data. So once the data is in some format, either JSON or some other format data which we get, we need to parse the data and store that, or either send it to some other system or store into HDFS. So what we are doing here is using invoke HTTP, we are getting the data in certain interval of time, and we do some of the parsing operations on top of it, or add any other attributes which are required, like timestamp. Here in this project we are getting the data in the form of complex JSON format, for which we parse the data into CSV and store it into HDFS, as well as send it to the output Kafka topic. There are two different routes. So once we add the timestamp and parse the data into CSV, we publish the data using the publish Kafka processor in NiFi. We publish the data onto the input Kafka topic. So once we publish the data onto input Kafka topic, that is raw data, which is parsed data we can call, now we have to perform some transformations on top of it using PySpark. So this PySpark will read this input Kafka streaming data using read stream function and perform into a data frame and perform some operations on top of it, and then write the output process data onto the output Kafka topic using write stream function. So that write stream function writes the data onto the Kafka output topic, which will be consumed using consume Kafka processor in NiFi. So that data, output process data from output Kafka topic, will be consumed using consume Kafka process, and this process data is then either parsed or directly stored onto HDFS using the put HDFS processor in NiFi. So this all processor need to be configured before they are executed, so that the dots will be connected. So we give all the XML configurations and everything in these processes, so that the data will be in a correct flow. So once the process data in the HDFS, we create a Hive table, external table on top of the data, and then query the data. We also add Apache Airflow for the data flow orchestration, either from Hive table, raw table to process table, or from HDFS to Hive. So we orchestrate this process using Airflow. This all flow is going to be shown in this mini project. Once the data is in queryable format, then we need to visualize the data. Now here in this mini project we are using two tools to visualize the data, which is Tableau Online and AWS QuickSight, to visualize the data for different KPIs. So this is the end-to-end data architecture. What we are not focusing on this data architecture is scalability, adding more number of nodes, and also the security aspect of the data. Like some of the fields can be actually provided security. In some of the data there can be personal identification fields like social security number, which need to be not to be directly shown to everybody. So there has to be a level of encryption to the data which needs to be provided as a part of data security. So I'm going to show you in this mini project, along with the data flow, how we can actually provide security to the data. I will choose some of the fields and encrypt that fields using NiFi, and then we can show how we can hash those fields and encrypt some of the fields and decrypt them at some level in order to provide the data security. So this is all about the data architecture which we are going to do in this mini project.